Okay, let's start with something we all know, right? The sun. Its core is, well, the hottest place in our solar system. But what if I told you that right here on Earth, scientists have built a machine that gets 5 times hotter than that? So what is this thing that's 5 times hotter than the sun? How on earth did they build it in a lab? And maybe the biggest question of all, why would you even try to build a star here on Earth? Well, the answers are part of one of the biggest, most incredible scientific quests of our time. All right, let's meet the machine behind this whole mystery. It's famously known as China's artificial sun. And yes, it's a massive piece of engineering designed to do something that honestly sounds like it's pulled straight from a sci-fi movie. So its official name is EAST. That stands for Experimental Advanced Superconducting Tokamak. Yeah, it's a mouthful, but its purpose is just incredible. To copy the exact process that powers the stars, nuclear fusion, but to do it right here on our planet. And this slide really breaks it down perfectly. You know, the real sun is this giant ball of gas, where gravity is so intense it forces atoms to fuse together at its core. The artificial sun? It's a high-tech, donut-shaped machine, that's the tokamak part, that uses some seriously powerful technology to do the same thing. And the goal isn't just to build a cool mini-sun, it's to unlock a source of virtually unlimited, totally clean energy.
And that really gets us to the big why. I mean, this isn't just some wild science experiment for the fun of it. It's a direct response to one of the biggest challenges we've ever faced as a species, our desperate need for a better way to power our world. Think about it. Our current energy sources all have some pretty major drawbacks. Fossil fuels, they create pollution. Renewables like solar and wind are amazing, but they kind of depend on the weather, right? And traditional nuclear plants, which use fission, splitting atoms apart, they create radioactive waste that lasts for a very, very long time. Fusion power, at least in theory, promises to solve all of these problems at once. This is exactly why you hear people call fusion the holy grail of energy. The fuel source comes from seawater, so it's practically limitless. It produces zero carbon emissions, no long-term radioactive waste, and this is a big one, it's super safe. There's no risk of a meltdown. If anything goes wrong, the whole reaction just stops.
So how exactly do you build a star in a box? It sounds completely impossible, I know, but the science boils down to a 3-step recipe. A very, very extreme recipe, but a recipe nonetheless.
Okay, first, you need unbelievable heat, just mind-boggling temperatures. Second, you need intense pressure to squeeze atomic nuclei together until they fuse into one. And third, and this is the really tricky part, you have to control the result. This creates a superheated gas called plasma, and you need a way to contain it so it doesn't just vaporize everything it touches instantly. So how hot are we talking? 150 million degrees Celsius. And no, that's not a typo. That's a temperature that is almost impossible to even wrap your head around. This chart really puts it into perspective. The core of our sun, the actual sun, burns at around 15 million degrees Celsius. To make fusion happen here on Earth, this machine needs to get 10 times hotter. That engineering challenge is just absolutely staggering. So how do you contain that? Well, you use these insanely powerful superconducting magnets cooled down to nearly absolute zero. We're talking minus 269 degrees Celsius to create a magnetic cage. This quote just says it all. It's literally like using Antarctica to contain a volcano. The coldest and hottest temperatures imaginable all in one machine. And this isn't just on paper. The EAST reactor is smashing real-world records. It recently held that super hot plasma at 120 million degrees for an incredible 101 seconds. That might not sound like a long time, but in the world of fusion research, that's a huge leap forward, proving the tech is getting better and fast. Okay, I know what you're thinking. This all sounds amazing, almost too good to be true. So what's the catch? If this technology is so revolutionary, why aren't we all using it already? Yeah, that's the big question, isn't it? Why isn't this already powering our cities and our homes? If we can literally create a star in a lab, what's stopping us from just plugging it into the grid? Well, there's one major catch. And here it is. Right now, all of these experimental reactors consume more energy to run than they actually produce. It's like spending $2 just to make one. We simply haven't hit that break-even point yet. But the roadmap is definitely there. China's next big goal is a new reactor called CFETR, and its whole mission is to be the first one to actually produce more energy than it consumes, with a target date of around 2050. But here's a part of the story that might actually surprise you. This isn't some new space race between countries. It's one of the greatest scientific collaborations in history. The breakthroughs from China's EAST reactor, they're shared directly with this massive international project in France called ITER. Scientists from all over the world are working together on this, basically sharing notes on how to build a star. So what does this all mean for you, and for me, and for all of us? Well, this research is laying the groundwork for a future that today sounds like something out of a utopian dream. Just let this sink in for a second. The fuel for fusion comes from stuff found in ordinary water. It's estimated that the fusion fuel in a single cup of seawater could power an entire house for hundreds of years. Just imagine that. A world with no more energy crises, no more fighting over oil. Ultimately, this whole quest isn't about one country winning some race. It's about human survival. It is one of our absolute best hopes for a sustainable future and a truly powerful tool in the fight against climate change. And hey, if 2050 still sounds really far away, just remember, the smartphone in your pocket was considered total science fiction not that long ago. This is the kind of science that is literally shaping our tomorrow. So what world-changing technology should we break down together next? I'd love to know what you're curious about. Should we dive even deeper into fusion? Maybe explore the wild concept of solar roads? Or should we try to unravel the mystery of quantum batteries?
let me know.